Violent wind drives the tower sideways, throwing the massive suspended weight into motion. When the tower reverses, the heavy mass keeps moving, swinging against the structure. That opposing motion pushes back through the suspension system, reducing the tower's violent movement. The swinging counterweight suddenly pulls its suspension cables into extreme tension. When the counterweight reverses, the loaded cables stretch, recoil, and pull it back. The cable tension pulls directly into the ceiling anchors, transferring the counterweight's opposing force into the structure. The violent counterweight movement drives the hydraulic dampers into motion. The pistons force hydraulic fluid through restricted passages, resisting the counterweight's movement. The hydraulic resistance slows the counterweight, sending the resisted force into the structural frame. The wind keeps driving the tower from side to side, repeatedly moving the suspended mass. Each swing meets hydraulic resistance, removing part of the motion before the next reversal. Swing after swing, the motion falls, until the tower settles into controlled movement. The wind keeps pushing, but the tower is no longer moving freely. The suspended mass moves against the sway, while the cables and hydraulic dampers resist each reversal. The wind remains powerful. The movement has been brought under control. Even with the sway controlled, powerful wind still bends the tower's central core. The bending core compresses on one side and stretches on the other, creating a powerful turning force. That bending movement reaches the outrigger level, loading the massive trusses that connect the core to the tower's outer columns. As the core bends, its movement violently pulls against the outrigger connections. The massive trusses engage the outer columns, turning the core's movement into opposing structural forces. The outer columns react against the trusses, creating an opposing force that fights the tower's rotation. The bending core forces the outer columns to carry an uneven vertical load. As one side compresses downward, the opposite columns are pulled upward under tension. As one side compresses downward, the opposite columns are pulled upward under tension. These opposing column forces create a counteracting moment that fights the tower's rotation. When wind strikes unevenly, the tower is pushed harder on one side than the other. That unequal loading makes the two sides move differently, beginning a twist around the tower. The twisting motion enters the interconnected perimeter frame, loading its beams and corner joints. The uneven wind pressure now drives the tower's outer structural frame into torsion. Connected beams and columns rotate slightly at their joints, carrying the twist around the The twisting force travels around the perimeter until it reaches the heavily connected corners.